Today we are going to solve one more important question by using the concept of vector differentiation. The question is, a particle moving with constant angular velocity omega in a straight line whose equation is given by r equals to a sec theta. Find radial component of velocity and transverse component of velocity. First, let us understand the meaning of radial component of velocity and transverse component of velocity. If a particle performing circular motion, then three important terms are involved. The three terms are radial velocity of the particle, linear velocity of the particle, and angular velocity of the particle. Let P be the point on this path and O be the center, and OP nothing but called as a radius vector, vector R, and perpendicular to radius vector is nothing but transverse direction, that is the vector S. Let theta be the angular displacement of the particle, R be the radius vector shown by vector OP, and R cap is a unit radius vector, and vector S is a vector perpendicular to vector R, and S cap is the unit transverse vector. The vector S is called as the transverse vector. As the particle moving along a given curve, the transverse vector always perpendicular to radius vector. Now, instead of circular path, let us consider any general curve, any given curve. So let us suppose this is any given general curve, and radius vector making an angle theta with the positive direction of x-axis. And vector S is a transverse vector perpendicular to vector R. Since R cap is the unit radius vector and it is given by R cap equals to cos theta multiplied by I cap plus sin theta multiplied by J cap, and transverse unit vector S cap equals to, since it is at 90 degrees, so it is given by cos of pi by 2 plus theta I cap plus sin of pi by 2 plus theta J cap. So these are the vectors R cap and S cap. As the position of point P is changing, then R cap and S cap is also changing, because R cap and S cap depends upon angle theta. As the theta changes, R cap as well as S cap is also changing. So position of the point P changes, then R cap, S cap both changes. S cap can be further simplified as S cap equals to cos of 90 plus theta nothing but minus sin theta. So S cap equals to minus sin theta I cap plus sin of 90 plus theta equals to cos theta. So cos theta J. So S cap equals to minus sin theta I plus cos theta J. Call it R cap as equation 1 and S cap as equation 2. Now differentiating R cap with respect to t, we get minus sin theta d theta by dt I cap. Why d theta by dt? Because theta is also changing with respect to time. Now from both the terms taking d theta by dt common, so we get minus sin theta I cap plus cos theta J cap, and now taking d theta by dt common from both the terms, call it 3 number. Now from the equation 2, minus sin theta I plus cos theta j is nothing but s cap. Therefore, dr cap by dt equals to, here is the s cap, and we get d theta by dt. Call is equation number 4. This is the relationship between dr by dt and s cap and d theta by dt. I would like to tell you that d theta by dt nothing but omega. In similar way, differentiating s cap with respect to t, we get this result, and after differentiating, taking d theta by dt common as well as minus common. So minus taken common, we get cos theta I cap plus sin theta j cap, and d theta by dt taken common. Call it equation number 5. Now from 1 and 5, from 1 we have already here that r cap equals to cos theta I plus sin theta j. Therefore, ds cap by dt equals to minus r cap d theta by dt. Call it equation number 6. Now let vector v equals to velocity of the moving particle at the point P, and we have already vector OP. Vector OP nothing but vector r. It is given by product of r and r cap, where r is nothing but magnitude of vector r. Now differentiating both sides with respect to t. So differentiation of vector r with respect to t equals to differentiation of r and r cap. Both are changing with respect to t. Therefore, both we consider as a variables. Therefore, applying product rule of differentiation, so we get dr by dt r cap plus r multiplied by differentiation of dr cap by dt. And in place of dr cap by dt, you can put s cap multiplied by d theta by dt. But dr by dt nothing but velocity. So velocity v equals to dr by dt multiplied by r cap plus r d theta by dt multiplied by s cap. In this expression, dr by dt, this term called as a radial component of velocity, and r d theta by dt, this term called as a transverse component of velocity. So given question is, a particle moving with constant angular velocity omega in a straight line whose equation is given by r equals to a sec theta. So we have r equals to a sec theta. We need to find radial component of velocity and transverse component of velocity. Now radial component of velocity is given by formula dr by dt, and transverse component of velocity is given by r d theta by dt. Since we have r equals to a sec theta, so dr by dt is equals to a differentiation of sec theta with respect to t, so that is equals to a sec theta tan theta multiplied by d theta by dt. But d theta by dt is nothing but omega. Therefore, in place of d theta by dt, writing omega. Therefore, dr by dt is a sec theta tan theta multiplied by omega. So that is equals to a omega sec theta, tan theta. So radial component of velocity is equals to a omega sec theta tan theta. So to find out radial component of velocity for any given equation in terms of r, you find dr by dt. Now how to find out transverse component of velocity? Transverse component of velocity given by r multiplied by d theta by dt. R is nothing but a sec theta and d theta by dt nothing but omega. Therefore, transverse component of velocity is equals to a omega sec theta. So this way we find out transverse component of velocity. Whenever they ask transverse component of velocity, then just find out r multiplied by d theta by dt, and wherever d theta by dt is there, you put omega. Therefore, in this case, transverse component of velocity is a omega sec theta. This way we find out radial component and transverse component of velocity. Next time we will talk about how to find out radial and transverse component of acceleration. Now one important question for you as a homework. The question is, in which part of the steam engine we obtain radial and transverse components of velocity? Please write down your answer in comment box.